Hey class, all right, so we're going to get into hypothesis tests for difference of means. So the idea here is that you're trying to test if there's a difference between the mean of some population compared to another population. So if you look at this example, it is generally believed that males speed more excessively while driving than females. Along a particular roadway, 1,000 people are recorded speeding, of which 640 are males and 360 are females. The average speed over the posted limit is 11 kilometers an hour for males and 8 kilometers an hour for females, with a standard deviation of 1.5 kilometers an hour and 4 kilometers an hour, respectively. Does the evidence support this claim? So the idea here is that you're trying to test if males speed more than women, or men speed more than women. And you're going to have to then, the important part here is you need to very clearly identify which is which. So I would say go about and label things. And it might even help to make a table prior to doing this, just to sort of set things up the right way. So let's say male. So I'm just going to make a little chart here. And female. And just for the sake of simplicity, we'll call this 1 and we'll call this 2, because we're going to have to label our variables. So x, or let's first of all say n. So how many were sampled? Well, n in total was equal to 1,000. We'll put it over here, I guess, total. So in total, there was 1,000 people sampled, right? 1,000 people recorded speeding. And what is it here? We have 640 of them are men. 360 of them are women. Okay, so this is n1 equals and n2 equals here. And I wrote down here a handy little reminder for myself. It's a small sample size if n1 and n2 are both less than 30. In this case it isn't, so that just means when we get to the formula we're going to have to use this formula right here instead of this formula right here. Now we need an average, and we also need a standard deviation, because if you look at the chart, we have x1 bar and x2 bar, s1 bar, or s1 and s2, and n1 and n2. So we need values for each of them. So the average speed over the posted limit is 11 kilometers an hour for men, and we're trying to test how far over the speed limit you go. And we have 8 for women. The standard deviation of 1.5 kilometers an hour for men and 4 respectively. Respectively just means if it's 4, 11, and 8 here, this should be 11 for men, 8 for women. That should be 1.5 for men, 4 for women. Forget about the total here. I just put down the total for n because it might be helpful. Don't worry about it for these two. There's no reason to total those out. All right, let's go. Let's start work through the process. So state the null hypothesis. 1, our null hypothesis is that men speed more than women. Well, sorry, that doesn't really... The idea is that there's no difference. The null hypothesis, the state of the world, in any one of these ones where you're talking about differences, is no difference. By the way, they sometimes label this D in the formula, but 0, we put 0 here because we're testing whether there is a difference. Well, the null hypothesis is then that there isn't a difference. 2, H1, we have mu1 minus mu2, and we have to figure out, is this less than 0 or bigger than 0? Well, if men speed more excessively than women, that means that mu1 should be bigger than mu2, if that's what we're trying to test, right? So this would make this equal to greater than 0. And sometimes if you want to think about it, mu1 is greater than mu2, because again, and this is why it matters which you label 1 and 2, because if this were men and this were women, this would have to be less than, but it's not. So 3, we have to do our determine the rejection region. We decided this was not a small sample. This is a large sample. So we can use a z-test. So our test statistic, or, well, I guess first of all, is it one or two-tailed? It's one-tailed because this is greater than, it's not equal to. We draw our little curve. Again, in all these questions, we're just going to use mu equals 0.05. I'm just going to walk you through this step, or not mu, alpha. I just walk you always through this step just in case you happen to ever get something that's not equal to alpha equals to 0.05. It's one-tailed, it's bigger than 0, so our rejection region is going to live over here. So Z alpha is going to be right here, and what this means is, well, we need to figure this out. If this right here is 0.5, or sorry, 0.05, then it means that this region in here should be equal to 0.45. Okay, we look on the chart. We find 0.45 in the Z table. 0.45 was actually right here because we have that nice little thing. So it's 1.645. So Z alpha is 1.645. And I'll just write it out over here to be more clear. 1.645. Now we compute the test statistic. So for the test statistic, and this test statistic is a little complicated in this case. It is x1 bar minus x2 bar minus d, where d is the difference, but we know the difference is 0 here. And generally the difference is going to be 0, so don't worry too much. In this class, it's mostly going to be 0. Almost always going to be 0, so if you're ever in doubt, just put a 0 there. Don't worry about it. S2 squared over N2. So now we got to plug everything in. We know this is 0. So x1 is 11. x2 is 8. D, the difference, well, we just want to know if there is a difference, not how big the difference is. So the difference is going to be 0 over the square root 1.5 squared over N1, which is 640, plus 4 squared over 360. I'd recommend computing this first. The computations here get a little tricky, so just make sure you're very, very careful. I'm just going to do it one step at a time. 11 minus 8 is just equal to 3 over, I'm just going to leave the square root in and just do this a step at a time. 1.5 squared divided by 640. I'm getting 0.003516 plus 4 squared, because I'm just going to do this term now, divided by 360. And I get 0.0444. Okay, so I'm going to add that to 0.003516, and then just take the square root. So I have 3 divided by 0.218, or let's just say 219. 3 divided by 0.219. I'm going to get this is equal to 13.6. Well, you know what? 13.7. Doesn't matter. 13.7 is going to be well above 1.645. So, 5, we reject the null hypothesis with 5% chance of type 1 error. 6, there is sufficient evidence to suggest men speed more than women. Okay. All right. Okay, I'm gonna just end this video. The next video, I'm gonna start doing a paired difference, which is similar to this kind, but there's sort of a calculator tip that I have to show you in that video as well. Something that'll help you compute things, especially on the test, when you've got a large table of data. Instead of having to go and figure out the standard deviation formula and all that fun stuff, you can just do it all in your calculator. So I'll try to walk you through that in my next video as well. Thank you very much.